Okay, imagine this for a challenge. You've got to build a car. Simple enough, right? But here's the catch. It can't drive on a road. It has to drive on a totally different world. A world with no air, crazy temperatures, and just 1/6 of our gravity. Oh, and you also have to fold it up like origami and ship it 250,000 miles away. Yeah. Let's dive into the absolutely incredible story of the lunar roving vehicle. So, just how big of a deal was this thing? Well, check this out. Before the rover, on Apollo 12, the astronauts could basically walk a few city blocks from their lander. That was it. But by Apollo 17, with the rover, they drove the distance of an entire marathon. This wasn't just a small upgrade, it was a total game changer for exploring the moon. So, why was a car so desperately needed? I mean, the early Apollo astronauts were some of the most capable explorers in human history, but they were literally tethered to their lunar module, their LM. Think about it. Every single step they took, they had to lug all their heavy equipment by hand, all while wearing those bulky spacesuits. Their life support was limited, which meant they just couldn't risk going very far. You can really see how the need for this evolved. The first missions, yep, all on foot. Then, on Apollo 14, they tried a little hand-pulled cart, which they nicknamed the rickshaw. It was a step up, sure, but dragging that thing through the superfine moon dust was just exhausting for the astronauts. The need for a powered vehicle became crystal clear. And just a few months later, on Apollo 15, the real deal finally arrived. Okay, now we get to the really wild part. How on earth do you actually build this thing? You know, the first ideas were for these massive, truck-sized mobile labs that would have needed their own giant Saturn V rocket just to get them off the ground. But NASA's budget, no way. That wasn't going to happen. The rover had to be a total marvel of efficiency, which kicked off one of the greatest engineering challenges you can imagine. The design team was basically handed an impossible checklist. The rover had to be unbelievably lightweight, but at the same time, strong enough to carry 2 astronauts in their bulky suits, plus all their science gear, and, hopefully, a lot of rock samples. But the real kicker? It had to fold up into a tiny space, and it had to be designed, built, and tested in just 17 months. I mean, that is an absolutely breakneck pace. And this just nails how tight that squeeze really was. The only spot left on the entire lunar module was this small, kind of awkward triangular bay. So the whole car, we're talking chassis, wheels, seats, antennas, everything, had to be compressed into a package about the size of a refrigerator. Just let that sink in for a moment. An entire car, squished into a fridge. Now, this was a serious investment. The total price tag for the 4 rovers they built was $38 million back then, which is nearly $300 million in today's money. But you've got to think about the return on that investment. For just a tiny fraction of the total Apollo budget, NASA basically unlocked the entire lunar landscape for its astronauts to explore. So how did they solve some of these insane design problems? Well, let's start with the wheels. Rubber tires? Forget it. A single puncture could strand the astronauts miles from their only way home. The solution was pure genius. A flexible mesh made of woven steel wire with little titanium treads for grip. This design couldn't get a flat, and it spread the rover's weight perfectly so it wouldn't sink into that soft, powdery moon dust. And what about that whole lightweight but super strong thing? The rover's frame was built from super light aluminum. Here on Earth, the whole thing weighed about as much as a big motorcycle. But on the moon, thanks to that low gravity, this lightweight frame could haul more than double its own weight in astronauts, tools, and all those precious moon rocks. Incredible. So they managed to design and build this impossible machine. But now, how did the astronauts actually get it out and use it on the moon? Well, getting it unpacked from the lander and onto the surface was this complex, carefully choreographed procedure that was, honestly, almost as impressive as the rover itself. They called it the unfolding ballet, and for good reason. It took about 20 minutes. An astronaut would pull a series of release cables, and then, using springs, the whole vehicle would pivot out, unfold itself, and lower to the ground. The back half would snap out first, then the front section, with the wheels just springing into place. It was a masterpiece of mechanical origami. Now, driving on the moon was not like a Sunday drive here on Earth. The biggest problem by far was the dust. The astronauts said it was like powdered snow. Incredibly fine, but because of static electricity, it clung to absolutely everything. Their visors, their suits, the rover, you name it. Those fenders you see over the wheels were absolutely essential to keep them from being completely blinded by the dust clouds they kicked up. And safety, of course, was everything. Every single trip was governed by a critical rule called the walk-back limit. Mission planners basically drew an invisible circle around the landing site. No matter how far the astronauts drove or in what direction, they always had to stay inside that circle. A radius where, if the rover just completely died, they could still walk back to the LM on their own oxygen supply.
So, after all that incredible design work, all that expense, and all that careful planning and operation, what was the final result? Well, the lunar roving vehicle didn't just help exploration. It completely redefined what was possible for a human being on another world. Its impact was, to put it lightly, monumental. The numbers are just staggering. Before the rover, astronauts covered, on average, about 3 kilometers on foot. With the rover, that average shot up to 30 kilometers. That is a tenfold increase in how far they could explore. It allowed them to visit geological sites that they never could have dreamed of reaching on foot.
And the program really peaked on the very last Apollo mission, Apollo 17. On that mission alone, astronauts Gene Cernan and Harrison Schmitt drove their rover a grand total of 36 kilometers across the Taurus-Littrow Valley, and they gathered some of the most scientifically important samples of the entire Apollo program.
You know, the rover's legacy is just immense. It kicked off a whole new era of science. It famously filmed that historic liftoff of the lunar module, giving us that iconic footage of humanity leaving the moon. And the engineering lessons learned from it, they directly influenced the design of the robotic Mars rovers we're so familiar with today. And now, over 50 years later, NASA is using all that knowledge to build the rover's next-generation successor. And that kind of brings us to a final amazing thought. Right now, 3 of these incredible machines are sitting silently on the surface of the moon, right where the astronauts parked them for the last time. They're basically monuments to human ingenuity. And it really makes you wonder, if this is what we could pull off over 50 years ago, what will the next generation of planetary vehicles make possible for us?